Thanks.
Good evening, students.
Good evening, sir.
Yep. Sorry for the late. So, as I discussed with you today, we are going to start. What topic we discussed today? We are starting. Students, please.
Complex numbers.
Complex numbers and quadratic equations. Complex numbers and quadratic equation.
Sir,
Yes.
sir, actually you didn't tell the general solution for sine square x, cos square x, and tan square x.
Sine square x, cos square x, and
Tan square x. General solution and
we will discuss, man. Let me start this topic. Okay.
okay, sir.
Yeah, I will discuss separately. Yes, sir. Today, tomorrow evening. This week, tomorrow is the last class. Might be one more class I am planning to take this week. Let me, anyway, I started. Yeah. Complex numbers. So we are having different number systems. We already discussed it in earlier classes. What are the number systems we are having as per our knowledge? Anyone can list out? Students, please. Students, please. Guys, what are the number systems we are having? To do so many things, we are having natural numbers. There is a problem of addition subtractions. So whole numbers, integers, rational numbers, irrational numbers, all together is called real numbers, etc. These are all these systems contains real numbers, but any one of the system does not explain root of negative values. I know how to solve root 4, root 3 also I can explain, root 2 also I can explain, but I can't explain what is root minus 4. Root minus 4 is not defined according to our number systems. Is it clear, guys, what I'm saying?
Yes,
Student?
sir.
Yeah. So for that, there is a situations and many times root of negative values are occurring in different situations, and geometrically and physics, even in physics also, root of negative values, there is no particular system they define. So root of negative values initially we can get in quadratic equations, where we will get ax square plus bx plus c is equal to 0 is a quadratic equation. The solution of x is equal to minus b plus or minus square root of b square minus 4ac by 2a. In this, b square minus 4ac is equal to delta is called discriminant. When discriminant is negative, they are not explained from based on our previous system. If the delta is negative, they said no solutions. What is the meaning of no solutions? Is it really no solutions? To understand these scenarios, they found that a new number system is called imaginary number system. That is, assume that root of minus 1 is equal to I. Assume that means any number square is always positive. The square of any number is positive, but I is a number called imaginary number. I is called imaginary number. The square of I is equal to -1. Then they assumed an imaginary number I. The square of that number is -1, which is not possible any of the real numbers. Which is not possible by any of real numbers. Then they are able to explain the concept of root of negative values with this imaginary number system. What it guys? What I'm trying to say, students?
Yes, sir.
Yeah. So from this, they found that I is equal to root of -1. Root of -1. So this means I is the solution of which equation? X square plus 1 is equal to 0, because x square is equal to -1, x is equal to root of -1. X is equal to root of -1. So I is the solution of x square plus 1 is 0. If I am writing a number, if any number frame are formed, combination of a real number and an imaginary number, then it is called complex number. With this definition, I can write any real number as complex number. Any real number as complex number also. Any real number as complex number also. That is, if a number is in the form of a number is in the form of a plus ib, where a comma b are some real numbers. A comma b are real numbers. A comma b are real numbers, and a plus ib is defined as complex number. Now I'm saying each and every real number I can call it as a complex number. So each complex number, if I am observing little bit closely, suppose if a plus ib is a complex number, it have two parts. A is one part, ib is another part. That is, a is called real part of the complex number, b is called imaginary part of the complex number. So if my imaginary part is 0, if my imaginary part, if imaginary part of a complex number is 0, then it is a real number. From here, I can write any any real number can be written as a complex number. Suppose if I am having 2 can be written as 2 plus I0. If I am having root 3 plus I0. If I am having root 5 plus I0. So any real number can be written as complex number. Each and every real number, that means all real numbers can be called as complex numbers, but all complex numbers can't be called as real numbers. If the imaginary part is exist, then it cannot comes under real. Is it clear, guys? What is the how I am explaining the complex numbers? Understood, guys? What I'm trying to say? Is it clear?
Yes, sir.
Yes.
Yeah. So we don't have very deep or in depth of the complex numbers. Just we are having the, like when we are learning the new numbers, what are the things we started when you are in kids? We started with additions, subtractions, multiplications, and divisions. That is the main thing. That is called algebra of numbers. If I am adding two numbers, subtracting, multiplying, and division. Same as now I defined a complex number. A plus IB is a complex number where I is equal to root of minus 1. A comma B are some real numbers. Any real numbers. Then A plus IB is called a complex number where the first part is called the real part of complex number and this part is called imaginary part of the complex number. IB is called imaginary part of the complex number. Now, how to add and subtract the complex number? So I am going to start algebra of the complex numbers. It's very simple. Yeah. So the first one is addition of two complex numbers. So before going into the algebra of complex numbers, comparison of two complex numbers. When two complex numbers are equal. Suppose if I am saying A plus IB is equal to P plus IQ. These two complex numbers are equal. Two complex numbers are equal. If and only if real part of one number must be equal to the real part of another number. Same as imaginary part must be same. Imaginary part must be equal to imaginary part of other number. Then only we can say both the numbers are equal, because how much real value? Suppose if A is equal to B, in this case, these two numbers are equal unless until if A is equal to B, A is equal to P, and B is equal to Q, then only I can say this is the real part of the left number and real part of the right number, and imaginary part of the left number, imaginary part. How many times I is multiplied? The same number of times I should multiply, because it is A is a value plus B times I. Same as P plus IQ means I is multiplied by Q times. So root of minus 1 is multiplied by some number of times. How many times root of minus 1 is repeating? The same number of times it should repeat. So based on the general knowledge of number system, we can able to explain if A is equal to P, B is equal to Q, then only I can say A plus IB is equal to P plus IQ. Based on this, by comparing the, if I'm saying two complex numbers are equal, based on this, we may have some numericals we have to face. Is it clear? Students? Understood? What is the meaning of equality of two complex numbers?
Yes, sir.
So addition of two complex numbers. Generally, complex numbers will be represented with Z. Will be general symbol. Z means any complex number. Let Z1 is equal to A1 plus IB1 is a complex number. Z2 is equal to A2 plus IB2. Suppose if I want to add, Z is equal to another complex number which is sum of two given complex numbers, A1 plus IB1 plus A2 plus IB2. Like our algebra, real part must be added with real part, imaginary part must be added with imaginary part. A1 plus A2 plus I into B1 plus B2. Is it clear, guys, what I'm saying? This is your addition of two complex numbers. So it is following. See, even after adding two complex number, the result is also another complex number. Might be it is 0 also, you will get another complex number. So it is following a closure property. What is the meaning of closure law? The closure law means if I am adding two natural numbers, I am getting two natural numbers. If I am adding two integers, I will get an integer. If I am adding two whole numbers, I will get a whole number. If I am adding two real numbers, I am getting two real numbers. The result is also real numbers. Same as the sum of two complex numbers is equal to, the result is, the sum of two complex numbers is equal to, the result is also a complex number. So this property is called closure property. So Z1, Z2 are two complex numbers and Z1 plus Z2 is equal to Z, where Z is also a complex number. This is called closure property. Anyone can give what is the meaning of commutative property of anything? Like generally when I'm discussing something, commutative property means what? Anyone can remember the commutative property? What is the commutative property of a numbers?
Sir, the order of the numbers don't matter.
Suppose if I'm doing any operations, order doesn't matter. It is possible only in addition and multiplication. Am I right?
Yes, sir.
Suppose if I'm saying 2 plus 3, 3 plus 5, both are same. But 2 minus 3, 3 minus 2, not both are same. 3 plus 2. This is correct. This is not correct. 2 into 3, 3 into 2. Not a problem. Both are same. But 2 by 3, 3 by 2, not same. Correct? If the order is changing, the expression value is not changing, then it is following the commutative property. Generally, commutative property holds good for addition and multiplication of the numbers. But subtraction and division, it won't work. Same as now I am discussing the addition of the two complex numbers, the commutative law. If Z1 and Z2 are the two complex numbers, or for any two complex numbers Z1 and Z2, Z1 plus Z2 is equal to Z2 plus Z1. So it will hold commutative law. Associative law. What is the meaning of associative law? Same as like commutative, but with three numbers. If I am having three complex numbers, I am adding Z1 plus Z2. After that, I am adding with Z3 is equal to adding Z2 plus Z3. After that, I am adding with Z1. Both are same. So So this is called associative law. For any three complex numbers Z1, Z2 and Z3. Z1 plus Z2 of Z3 plus Z3 is equal to Z1 plus of Z1, Z2 plus Z3. I'm adding these two and I'm adding with Z1. So it doesn't matter. So this law is called associative law. The next one is additive identity. Anyone can give what is the meaning of additive identity? Additive identity, multiplicative identity. Anyone can, what is the meaning of identity? Even though if I am adding something, if it is not losing its value, then it is
Value.
additive identity. What is the additive identity of a numbers? 0, no? 1 plus 0, 1. 2 plus 0 is 2. So 0 is the additive identity of the number, correct?
Yes, sir.
So the existence of, there is a existence of additive identity. Existence of additive identity. So 0 plus I0 is a complex number which is called additive identity. If I am adding this complex number to any complex number, if I am adding this complex numbers to any complex number, the value of that complex number will not change. Suppose if I am having Z is equal to A plus IB, if I am adding Z plus 0, where 0 is O, Z plus O. So A plus IB plus 0 plus I0, that will give A plus IB. So Z plus O will give Z. So this is called additive identity. Additive identity of complex numbers exist. What is a multiplicative identity, guys?
1, sir.
1. So the last property of the addition, existence of additive inverse. Existence of additive inverse. What is the meaning of additive inverse? Suppose what is the additive inverse of 2?
-2.
Additive inverse of 4?
-4.
Additive inverse of -10 plus 10. So in natural numbers, additive inverse is not possible, but in integers, additive inverse is possible, correct? Existence of the additive inverse in natural numbers is not there. Am I right or wrong?
Yes, sir.
Additive inverse of 2 is -2, but -2 is not a natural number. When I'm talking about natural number, additive inverse is not possible. So the existence of additive inverse to every complex number Z is equal to A plus IB. There exists a complex number minus Z is equal to minus A minus IB. This can be written as minus A plus I into minus B. It is denoted by minus Z. Is called additive inverse of Z. So Z plus minus Z is equal to 0 plus I0. So if exists any, for any set of numbers, another number which is existing in such a way, after adding that number to the number, I'm getting 0. Then this number is called additive inverse of Z. So minus Z is additive inverse of Z, or Z is additive inverse of minus z. Like 2 is additive inverse of minus 2 or minus 2 is the additive inverse of plus 2. Is it clear? Existence of the additive inverse.
Yes, sir.
So same as subtraction of two complex numbers. We are not going to discuss any properties here. Subtraction of two complex numbers. Subtraction of two complex numbers. Here also same. If I am giving two complex numbers, Z1 is equal to A1 plus IB1, Z2 is equal to A2 plus IB2. If I am saying subtract, Z1 minus Z2 is equal to subtraction of real numbers, real part plus I into subtraction of imaginary part, where the order is important. Z1 minus Z2 is not equal to Z2 minus Z1. That means what? It is not commutative. Subtraction of the two complex numbers is not commutative. Is it clear? What is the meaning of subtraction? How to do the subtraction of two complex numbers?
Yes, sir.
Yeah. So I will give one just simple question. Z1 is equal 6 plus 3i. Z2 is equal minus 2 plus I. Find Z1 plus Z2, Z1 minus Z2. Please just give the numbers, addition of these two complex numbers and subtraction of these two complex numbers. How you will do?
Sir, addition is 4 plus I4.
Okay. See, when I'm doing addition, what is the rule I have to keep in mind? When I'm doing addition of two complex number, 6 plus 3i plus minus 2 plus I. So 6 plus minus 2, that is 4, 3i plus I, 4i. Correct?
Yes, sir.
When I'm talking about subtraction, the order is important. I already told you. 6 plus 3i minus 2 plus I. So I can subtract real part with real part and imaginary part with imaginary part. That is 6 minus of minus 2 plus 3i minus I. This will be 8 plus 2i. Correct? Is it 8 plus 2i?
Yes, sir.
Yeah. Suppose it's the same multiplication of complex numbers. Student, just hold on a second. Sorry, students. Yeah, multiplication of two complex numbers. How to do multiplication of two complex numbers? It looks like same as algebra. Suppose if I am having a complex number, Z1 is equal A plus IB, Z2 is equal C plus ID. Suppose if I am asking multiply Z1 into Z2, A plus IB into C plus ID. Take the real form and multiply all the terms of the second number and take the imaginary part, multiply with all the parts of the second number. So if I'm multiplying with A into C plus A into ID plus IB into C plus IB into ID. So this will give AC plus IAD plus IBC plus I square BD. So according to the definition of the complex numbers, I square is equal to -1, correct?
Yes, sir.
So from here, wherever there is a possibility of reducing the I into a real number, you have to reduce. If not, you can keep it in a imaginary part only. So now you can see clearly this is real, these two are imaginary. Collect all the real parts of the number, collect all the imaginary parts. AC minus BD plus, if I'm taking I common, because I further I can't reduce, because I itself we are assumed to understand the root of negative value. So AB plus BC. This is the product of Z1 and Z2. Is it clear how to do the multiplication? If you are able to remember how to multiply AX plus B into CX plus D, that is enough. This is simple. Hope you are clear how to do the multiplication of these two complex numbers. Is it clear, guys?
Yes,
Yes,
sir.
sir.
So take the previous data. Take the previous data. What is the in previous question? What is Z1 I gave for addition? What is the Z1 I gave for addition?
6 plus 3i.
6 plus 3i. What is the Z2 I gave?
-2 plus I.
Minus 2 plus I. So find the Z1 into Z2. And it is also a complex number. So the product of two complex number is a closure property, because the product of two complex numbers again I am getting as one more complex number. So it's a closure property. So one property I discussed. The product order might be anything, Z1 into Z2 or Z2 into Z1, both are same. So it is commutative property. The multiplication of two complex numbers will follow commutative also. So some other properties we will discuss. Just find the Z1 into Z2 and what is the Z value you are getting, please.
Sir, it's at -15.
One second, I am coming to. Yeah. So I'm going to calculate the product of two numbers. Z is equal to Z1 into Z2. 6 plus 3i. Initially, to understand, if you people are confusing, I'm unable to do direct multiplication. Just write the steps. 6 into -2 plus 6 into I plus 3i into -2 plus 3i into I. This will give us -12 plus 6i minus 6i plus 3i square. Since I square is equal to -1, -12 plus 0i plus 3 into -1. So -15 plus 0i, which is actually a real number. Its imaginary part is 0. So It need not to be the product of two complex numbers is always a complex number, but any real number can be written in the form of the complex number. Like any integer can be called as the whole number, but all the whole numbers are not real numbers, sorry, natural numbers. Like that, any complex number, sorry, any real number can be written in the form of the complex number, but all the real numbers also can be called as complex numbers where its imaginary part is 0. If the imaginary part is having some value, then it will not come under real numbers category. Is it clear, guys? What is the overview of the complex numbers?
Yes, sir.
Now, I'm going to discuss the different properties of the, how we are going to explain. I already discussed closure property and commutative property. What is the closure property says? The closure property says the product of two complex numbers is a complex number. The product of two complex numbers is a complex number. Second one is commutative property. Commutative law, property or law. Product of Z1 and Z2 will be equal to Z2 and Z1. Next one is associative law. Z1, Z2 product multiplied with Z3 will be equal to Z1 of Z2 and Z3. For any three complex numbers of Z1, Z2, Z3. Existence of multiplicative identity. Anyone can explain? Existence of, what is the meaning of multiplicative identity?
So the number multiplied by the multiplicative identity will give the same number.
Yes. What is the multiplicative identity of general numbers? 2 into 1, 2. 3 into 1, 3. Additive identity is 0, multiplicative identity is 1. Same as the multiplicative identity of a complex number is 1. Z1 plus, sorry, Z1 into, suppose if I am taking Z1 is a complex number into 1 plus 0i, it will give Z only. Am I right?
Yes, sir.
So the multiplicative identity of a complex numbers is 1. 1 is also a complex number. It might be a real number, but it's a part of the complex number. So 1 plus 0i. Is it clear? What is the existence of multiplicative identity? When it comes to additive identity, it is 0. But when it comes to multiplicative identity, it is 1. Same as the important one to understand the division of the complex numbers, existence of the multiplicative inverse. Existence of multiplicative inverse. What is the general multiplicative inverse of a real number? Suppose if I am taking 3, what is the multiplicative inverse?
1 by 3.
Yeah, 1 by 3. After multiplying with multiplicative inverse, the answer should be unity. Suppose the multiplicative inverse of 2 is 1 by 2. Answer is 1. The multiplicative inverse of minus 3 is minus 1 by 3. The answer is plus 1. Understood what is the meaning of multiplicative inverse?
Yes, sir.
So generally, if I'm having a number x, its multiplicative inverse is x power minus 1. Same as if z is a complex number, where z is equal to a plus ib or a plus bi. There exists a complex number such that z power minus 1 is called multiplicative inverse of z. That will be equal to z inverse is equal to, I can write as 1 by z or 1 by a plus ib. But 1 by a plus ib is the not standard form of the complex number. So how to write the multiplicative inverse of a complex number? Z into 1 by z is equal to 1. So I can say 1 by z is the multiplicative inverse. So here I am using the concept of multiplication to write the standard form of z inverse. 1 by z is equal to a plus ib. I am multiplying a minus ib on the both the sides to check whether the existence for any number where a comma b is any real numbers. I am not taking particular numbers. This will be a minus ib by a plus ib into a minus ib. This will be a square minus ib whole square according to the concept of x plus y into x square minus x minus y formula. So a minus ib divided by, this is a square plus, sorry, a square minus I square b square. We know I square is how much? Minus 1. So a minus ib by a square minus of minus 1 into b. This will be a minus ib by a square plus b square. If I am separating the real part and imaginary part to represent whether it can form a complex number or not, a by a square plus b square plus I into b by a square plus b square is the z inverse.
Minus b.
Yeah, minus b is z inverse. So if I am giving a number by seeing the number immediately, suppose 3 plus 4y is z, its multiplicative inverse is how much? 3 by how much?
5.
3 by root of
Root.
3. Sorry, not, is it root is there? No,
No, sir, only 25.
3 square plus 4 square plus I into minus 4 by 3 square plus 4 square is the multiplicative inverse of 3 plus 4i. If not, if you are unable to remember this formula, just write the multiplicative inverse of z is 1 by z. That is nothing but 1 by 3 plus 4i. But 1 by 3 plus 4i is the not standard form of the complex number. That's the reason 3 minus 4i by 3 minus 4i, if you multiply, convert into standard form, whatever the complex number you are getting after doing this operation, that is your multiplicative inverse. Is it clear, guys, what I'm saying?
Yes, sir.
Distributive law. It's a combination of both the product and addition. Distributive law holds good for complex numbers. Distributive law over multiplication and addition. So any three complex numbers Z1, Z2 and Z3. If I am multiplying Z1 with addition of Z1 plus Z2, sorry, Z2 plus Z3, I can distribute this one like this: Z1 into Z2 plus Z1 into Z3. This is only called distributive law. Or I am having Z1 plus Z2 multiplied with Z3. I can distribute Z1, Z3 in plus Z2, Z3. This is a multiplication distributive law. Shall I go for the last operation before going to the numerical? What is one more algebraic operation remain? What is remaining? Multiplication is over, addition is over, subtraction is over. What is remaining? This concept we can do in simple ways. Suppose if Z1 is equal to A plus IB, Z2 is equal to C plus ID. The division of Z1 by Z2 is nothing but A plus IB by C plus ID. That is nothing but Z1 into multiplicative inverse of Z2. Understand what I'm saying?
Yes, sir.
This can be written as A plus IB into, what is the multiplicative inverse? C by C square plus D square plus I into minus D by C square plus D square. So now it is ready to multiply because I don't know how to do the division. So division is nothing but multiplication of the numerator with its multiplicative inverse of the denominator. I have to multiply the numerator with denominator multiplicative inverse. This is a straight formula. Sir, I am not comfortable with formula. Simple. Z1 by Z2 is nothing but A plus IB divided by C plus ID. Simple. No need to remember this one. Just multiply both the numerator and denominator with C minus ID. Then whatever the answer you are getting, that is the division of Z1 by Z2. Is it clear, guys, what I'm saying?
Yes, sir.
Let's see why I'm getting same or not. A plus IB into C minus ID divided by C square minus ID whole square. So this A plus IB into C minus ID by C square plus D square. A plus IB into C by C square plus D square plus I into minus D by C square plus D square. See here. Just for the definition purpose, I am saying I gave the formula, but even without the formula also you can able to do the division of two things. Division of two complex numbers means nothing but Z1 by Z2 is nothing but multiplication of Z1 with multiplicative inverse of Z2. We are multiplying two complex numbers, Z1 into 1 by Z2, that is nothing but Z1 into multiplicative inverse of Z2. So this is only known as division of a complex number with another complex number, that is nothing but another way of multiplying. We don't have any particular process for division like numbers. It's entirely different here. Is it clear? It is also a multiplication, but you are multiplying with the multiplicative inverse of the denominator. That is the meaning of division of two complex numbers. Is it clear? Power of I, square root of complex number. So square root of a negative real number we will discuss in tomorrow. Identities, and after that almost this is the end of the complex numbers part. Next one is how to represent this complex number system in a organ plane. Like your XY coordinate system. What is the meaning of organ plane? I am going to explain. So operations of complex numbers, organ plane and quadratic equations. These three concepts is only there in complex numbers. So I will try to request one more extra session in this week with Raghava sir. Then we can wind up with including numericals, complex numbers in this week itself. Next week also one more class we can sit over the only numericals of the complex numbers. So shall I wind up the session?
Yes, sir.
Yes, sir.
So we'll meet in the next class. Bye everyone.
Thank you, sir.
Thank you, sir.
Thank you.